everyone! Now, before diving into the cool parts of shaders, we first have to understand what shaders are and how to write them. So, to simply begin, shaders are very fast programs which tell Godot how to draw things on the screen. They are so fast because they run on the GPU, which has many cores, allowing the program to basically run in parallel. Now, because of that, whenever we write shaders, we'll have to think a bit differently than we would when writing, say, a normal program that runs on the CPU. For a normal program, you always have the previous steps available, and you can make use of those steps in order to find out what happens in the current step. But since on the GPU everything happens in parallel, we can't really do that, so instead what we have to do is to find a way to know ahead of time what value the current, say, pixel or vertex that we are applying the shader on is going to be. Okay, but keeping this in mind, let's actually start writing some shaders. Okay, now let's begin by creating a shader for our sprite 2D here. To do that, we have to first create a material, so I'm going to go under the material tab and select a shader material. Now, to change how this material looks, we have to actually apply the shader that we're going to write, so let's just create a new shader for that as well. And let's call this shader base or whatever, everything is fine as it is, and after I open it, you see that I have here two functions. These functions are programmable steps of the rendering pipeline, and we can use them in order to say how the sprite should be rendered. For example, the vertex shader here, or the vertex function, is going to be called for each of the vertices of our sprite 2D and can be used to change properties of these vertices. So for example, we could change the position of them or even the color of the vertices. On the other hand, the fragment shader or the fragment function is going to be called for each pixel of our sprite 2D here. Alright, but we wouldn't be able to do much with only these functions without also being aware of the shader built-ins. The shader built-ins are basically just values that we have from the start and give us context on the object that we're working on. So, for example, a very useful built-in is the, well, vertex built-in, and this vertex built-in gives us the coordinates of the current vertex. So, if I want, for example, to change each vertex to be 20 pixels to the right, what I could do would be to simply write vertex.x. I'm taking the horizontal coordinate and I'm making it to be equal to vertex.x plus 20. And now what's interesting is that despite the object remaining in the same place, it's being rendered 20 pixels towards the right. Okay, but what else can we do? Well, there is also a nice built-in, which is time, and that built-in is going to tell us how much time passed since we started the engine. So for example, if I write here time, I'm adding to the x coordinate the time that passed, and as you can see, my vertices continuously move as this value is continuously changing. Okay, but let's put it back to 20.0 and let's move on to changing how each pixel is being rendered in our fragment shader. To change the color of a pixel, we have to use the color built-in. So I'm going to use color and to set it to be equal to some color that we want to provide. So as you know, a color has three color channels, red, green, and blue, and also another channel for transparency. So we can choose any values between 0 and 1 in order to specify how much of that channel we want to apply to our color. So for example, what I could do would be to write here, let's say 1.0 for red, 0.5 for green, and 0.5 for blue, and finally 1.0 for transparency. And as you can see, we changed every single pixel of our image to have this pink color. Similarly, if we were to go in 3D, we could, for example, assign a material to this cube here as well, and let's call it, I don't know, cube.gdshader. I'm going to create it, and after opening it, what I could do would be to also change the color of this. However, since this is a 3D object and the color is calculated slightly differently, what we have to specify instead is the albedo and the alpha of our cube, which are just another built-ins that we can use for 3D. So if I want, I could write albedo and make it equal to vec3 of 1.0, 0.5, and 0.2 this time. And as you can see, the cube is now this yellowish color. Okay, and if I want to make the cube be transparent, what I could do would be to write alpha and make it equal to 0.3, for example. Now you see that I have a very glassy cube here. Okay, now what I've just shown you are the essential built-ins that you're going to need if you want to write any shader at all. There are many other built-ins that we are definitely going to cover, but for now what I would like is to get back to our 2D shader, and in here I'm just going to zoom in so that you can see better. And what I want is for you to look carefully at how I added these values to my color. I had to specify that this group of values is a vector 4. So it turns out that shaders have data types. So for example, if I wanted to add a boolean, which is true or false, I would just have to write bool and something, I guess, and make it equal to true. And also you might notice that I have to add a semicolon after every line. This is just how we have to write code in shaders, and that's perfectly fine. Nothing to worry too much about. Okay, now what else do we have? Well, we have numbers. You know numbers. Numbers can be integers, can be floats, and you probably also know how to declare them. But for the sake of completeness, if I want to make a number, I have to write int number and make it equal to, say, 5. And if I want to make a float, I'd have to write float other number. Very high budget on the creative department today. And yeah, I could be setting this to be 5 as well. Now you might notice that I have an error. And this error is quite a pain when writing shaders, to be honest. But shaders do not automatically cast values. So if I said that here I need a float, here I need to specify a float. And 5 is an integer. So what I have to do is to write 5.0, and now this works. Another thing I can do is to just write 5 point, or if I were to have like a 0.1, I could just write 0.1. But this point is very important. So if you're wondering why you're getting that error, it's because you didn't put 0.0. Okay, but other interesting types of variables that we have is just combinations of these. So for example, if I wanted to have 2 integers or 2 floats, I would write vec2 and 2 floats and make it be vec2 of 1.0 and 2.0. And of course, if I wanted to have 2 integers, I could write ivec2, 2 ints, and make it equal to ivec2 of 1 and 2. And as you can see, this works perfectly fine. Now, this vector type goes up to 4, so we can have up to vec4, and we can also have a matrix in case we need more of these vector types. So what I could do, for example, would be to make a mat2, which contains 2 vectors, and I could say that this mat2 is matrix, if I know how to write, and mat2 of, I don't know, vec2 of 1.0, 2.0, and vec2 of 3.0 and 4.0. And now I have a matrix that basically looks like this. Maybe it's easier to visualize like this. It's just a table that contains 1, 2, and 3, 4. So nothing too special. And again, just as vectors, this matrix can go up to 4. Okay, we know how to write variables, but how do we actually use these variables? Well, what we could do first of all for integers and floats is to simply take their value. This is kind of straightforward. I can just take other number and put it here in the red channel and maybe change it to a reasonable value, 0.75, and you see that it changed the color of my rectangle. Now, if I wanted, for example, to do the same thing for number, well, I'd have a small issue because, again, I need to be very precise with the type that I have. So what I have to do is to just cast this to a float. So I could write float, and now my number is going to be transformed to a float, and I can make it like 1 so that it's the largest possible value for our green channel. Okay, now what if I wanted to get some value from inside this vector? Well, with vectors, it's a bit more interesting because you see, in shaders, vectors are generally either considered to be colors or considered to be positions. So there's actually two ways in which we can do the same thing, and to better show that, I'm just going to make a new vector 4, and if I wanted to refer to the first element of vector 4, and if I thought of vector 4 as a position, what I could do would be to write v4.x, for example. So I'm just going to take this v4.x and put it instead of this first number, and as you can see, the color changed because this v4.x is equal to 0.1. Okay, but if I think of v4 as a color, what I can do is to say v4.r, because this is the first element that the color has, because the color has RGBA. So if I wanted to make a completely new vector that's exactly the same as this vector, what I could do would be to write vec4, I don't know, v4 new, and set it to be equal to v4, and to take all of the color channels or all of the positions of this vector. So what I could do would be to write x, y, z, w to get all of the positions, or I could write RGBA to get all of the parts of the color. But behind the scenes, what I did was precisely to just get these values. So now I could even replace this whole vector 4 that's here and put it here instead of the color. And as you can see, I have this new color here. And maybe let's make this last value 1.0 so that we always have this perfectly non-transparent square. Actually, the border of this has been quite annoying, so I'm just gonna remove this. Okay, this is much better. Okay, but one interesting aspect of this is that there is a thing called Swizzling, which allows us to specifically select any part of our vector. So, for example, I could only, if I wanted, select the first element 4 times. So instead of RGBA, I could say RRRR. And I would get like this new square. Or I could like combine these however I wanted. I could say RG and taking the red and green channels. Or I could even swap it up to get positions. So I could write X, Y, Y, Z, and or X, Y, Y, W, why not? And you see that this color keeps changing with the proper values that I'm sending from this vector 4 here. Okay, but that's not even everything. If I wanted, for example, I could get just a few of these elements. I could get, for example, a vector 2 and v2 new and make it equal to v4 dot xx. Why not? I could do something like this, or I could do the same for a vector 3, and you get the idea. I can pick pretty much everything I want. One thing to point out though is that you can't really combine colors with positions because that doesn't really make sense. So if you were to write X and R, for example, you would see that you'd get an error. But yeah, I think that's a pretty reasonable thing to expect. Okay, now let's up our needs and let's say that we want to be able to change the color directly from the editor because changing these values also in the RGB system is kind of like unintuitive. So we want to have like an easy way to change these values. Well, we can do that through a uniform. So if I wanted, I could come here at the top of the shader and specify uniform and give the uniform a type. And since the color is a vector 4, I'm just going to write vec4. And for this uniform vec4 that's going to be named color, I'm just going to give, let's say, an initial value, which could be equal to vec4 of 0.0, 0.0, 0.0, and 1.0. Why not? And by default, I made my color black. So now I can set it to my built-in color. And as you can see, my square is black. Wonderful. Okay, but as you might notice, this does not help too much because the values that I'm getting here are still numbers. So what I can do is to give the editor a hint so that it knows that I want the color here, that these values does not represent just a number. And to do that, I simply had to add this colon and I have to specify source color. And now the editor knows that this is a color and gives me this wonderful interface that lets me like pick all these colors. And yeah, you might have seen the pattern that if I can do this for a vector 4, I can do this for pretty much everything. So I could create a uniform that allows me to get an integer, and that integer could be like number int something and make it be what? Well, I want this integer to be within a range, for example. So I could say to the editor, hey, this integer is going to hint a range that starts at 0, goes to 100 and has a step of 1. So we increment with 1 unit every time in this range. If I now put a semicolon here, you see that whenever I increment, this number goes up by 1, and I could make this increment be like 5, and after I increase, you see the number goes up by 5, and after I reach like 100, you see that I can no longer go up with this increment. The same thing I can do for float numbers, so float, and I don't know, let's just call this n2, and I can set a range to this as well, and as you can see, I have a slider for float numbers, because if I don't specify a step, I can pretty much like pick any value, and you wouldn't really be able to pick any value with just arrows. So it's nice that we have a slider. One other interesting thing that I could do would be to specify an enum. So if I wanted to select from a bunch of things, I could make, let's say, my enum and hint towards the editor that this is going to be an enum. And you see that it already populated with some values, but I could write here peanuts or something. And I have this drop down here now from which I can select peanuts 1 or 0. And these values map to the index of the element in the dropdown. So 0 would be 0, 1 would be 1, and peanuts would be 2. Now finally, there is one more thing that I didn't show you, and there's actually one more data type which I intentionally omitted because I didn't want to make it too complicated at the beginning. So we could also get reference to a texture or a sample of a texture. So what we can write is uniform and sampler to D. And with this sampler to D, I maybe call it my text, I can collect any kind of texture. So as you can see here, this allows me to select different kinds of textures, for example, gradients, or even like noise textures, which are very, very useful in shaders. And I can use this fast noise light texture to maybe make some fire effect or something. Alright, now while it might not be very obvious, with these parameters we have a little problem. And what's the problem? Well, if I duplicate this sprite, I now have 2 of these squares. So what happens if I go to my sprite here and let's say that I change this color to something else? Would you look at that? This other color changes as well. So then what can I do to have this unique, to not change this color of my new object? Well, there are a few things that I can do. For example, what I could do would be to use the instance keyword. So for example, I could write here instance in front of uniform, and now you can see that this uniform is going to be set only for the current instance, and also it's going to vanish from shader parameters, and it's going to appear, if I click again, under instance shader parameters, and from here I can like change per instance how my shader looks like. Now another way of doing this would have been to leave everything as it is and to instead delete this sprite 2D that I have here and simply create a new one which takes as a parameter, or as a shader rather, this different shader. And as you can see, because it's not a copy of the initial one, when I change the shader and the color of this, it's going to only change for my singular sprite. Now another keyword that we have is the varying keyword, which basically just allows a variable to be passed from the vertex to the fragment shader. So for example, I could write varying float sum val, and I could like modify this sum val to be 0.7, and afterwards I could take this sum val and have it be used here as the value for the other number. Okay, now before finishing, we still have to go over a few minor things. So just like in any other programming language, you have ifs and switch cases and loops and fors and whatever, and it's actually quite easy to write them. You can, for example, just write an if, and if something, then you do something, and else, otherwise you do something else. So it's not that big of a deal. However, what's interesting is when we get to write a switch case, and if I write a switch, if you come from C, this is going to be no surprise to you, but what I could do would be to have in this switch, let's say this number, and I could say that in the case this number is 1, I want to do something. I could maybe make this other number to be equal to 0.73. Why not? So in the case this number is 2, I could set this number to be 0.77. And in the default case, in the case that's not 1 or 2, so default, I can set this other number to be like 0.1. Why not? Now, what's important to know here is that if I enter a case, I am going to go down the other cases as well. So, for example, if I enter case 1 and I want to set the other number to 0.73, what's going to happen is that I will also enter case 2 and the default case. So if I don't intend to enter case 2, after entering case 1, what I have to do is to break out of this whole switch so that I don't go over these other 2 instructions, and the same for case 2. And it really doesn't matter for the default case because, yeah, by default, you get out of the switch statement anyway. Now, another quirk to be careful about is the while statement. If you want to make actually any kind of loop, if you know that the loop is going to never finish, Godot will crash because these shaders are running all the time. So for example, if I were to write here while and add a condition, what would happen would be that Godot would instantly crash. So if I said while something here, I wouldn't have time to like come in here in parentheses and change the value of something. So what I have to do is in advance to change this value and only then to add the condition, or otherwise, as I said, Godot will crash. So let's say that we want to make this number reach the value of 5. Well, let's say that this number is going to equal to number plus 1, and afterwards, let's say that the condition is that number is going to be less than 5. And as you can see, nothing happens, everything is fine. However, just for the sake of completeness and for the sake of my pain, I'm just going to crash Godot again and write while number is less than 5. Oh, would you look at that? I can't write anything, and yeah, Godot is starting to crash. So yeah, really be careful about writing loops. First, write the exit condition, and afterwards only write the actual condition that the shader is going to check. Yeah, and talking of loops, there's also fors, which are actually quite safer because you can specify the exit condition ahead of time. So if you've ever written C, this should be nothing new to you, but if you haven't, what you have to do is first of all to initialize the variable with which you're going to loop. So let's just make int I, for example, equals to 0. So I initialize this to 0. Then you add a semicolon. Then you add a condition to stop. So I is smaller than 5, and then a semicolon. And the way you increment this I. So you could increment this I by 2 elements all the time, or you could... No, it's not safer. Apparently it breaks as well. Yeah, if I don't increment I in any way, then I is going to be forever smaller than 5. Oh man. Don't do for loops. Don't do for loops. Don't do anything. But yeah, what would loops be if we didn't have like an array type over which we could loop? So if you want, you could like define an array with int and parentheses and call it R, why not? And you just have to add here like 1, 2, 3, 4, 5, and then you have defined your array which contains these elements, and you can do whatever you want with them, just like you did here with the vector 2. You can just get R of 1, and it's going to get the element on this position because this is R of 0. Okay, but this is pretty much it. Anything that I might have missed, you can probably find in the docs. And if you got to this point in this arguably boring video, because it's like just presenting the syntax of all of this, I want to congratulate you because this is a great first step towards learning shaders, and it's going to get much more interesting from now on. But yeah, thanks a lot to my supporters, thanks a lot for watching, and see you in the next one. Bye bye!